Do you like books? I mean, really, really like books? Then you're in the right place. Each week, your host, Sam Hankin, interviews the best of today's top-selling authors and the up-and-coming superstars of modern literature. This is The Avid Reader. Here is your host, Sam Hankin.
Hi, everyone. Welcome to another edition of The Avid Reader, brought to you by Wellington Square Bookshop here in Exton, Pennsylvania. Today, our guest is Chris Ferrie, author of Where Did Our Universe Come From? And Other Cosmic Questions, Our Universe from the Quantum to the Cosmos, published by Source Books. Oh, and I forgot his author is Geraint Lewis. His co-author is Geraint Lewis. He also wrote Quantum Bullshit, How to Ruin Your Life with Advice from Quantum Physics. I've been there, going there sometimes. So Chris is an associate professor at the University of Technology, Sydney, and Center for Quantum Software and Information. He's also written tons of books for the Baby University series, such as Quantum Physics for Babies, which is like one of the first ones, Newtonian Physics for Babies, Rocket Science for Babies, General Relativity for Babies. And then when I kind of lose them is Statistical Physics for Babies, Blockchain for Babies, and Bayesian probability for babies. We can talk about that. Because, reading is, you don't really have to understand it, but just to give you an idea, or like he says, to light the spark, which is almost kind of like the universe starting from quantum fluctuations. You just start something like a chainsaw by pulling the rope, and then all of a sudden, all this stuff happens and you cut down trees, or all kinds of stuff like that. Anyway, and also reading, like when I was a kid, I read cereal boxes and, I liked them and I liked reading it. It was interesting. So anyway, we'll talk about that stuff. So the universe, we're all in it. We can't get out of it, which makes it kind of tough sometimes to imagine it and experiment with it because we can't look at it from the outside. But Chris approaches the whole thing from the very, very big to the very, very little. So I guess first, for me, what is a quantum? And Chris may disagree with this, but I understand it to be the smallest discrete unit of a phenomenon. So for example, a quantum of light is a photon and a quantum of electricity is an electron. And you think maybe there's stuff inside of them, but they're not. Because you always read about protons and neutrons and they have a bunch of quarks, up, down, strange charm, and top and bottom, which comes from, I own a bookstore, so it comes from Finnegan's Wake by Anne Murray Gell-Mann, figured it out, or called it that kind of whimsically. And it's funny because I was a lawyer too, and in law, quantum is an amount of damages in a case, which kind of correlates in a strange way. And the thing about it is all the parts of this book are quantum-y. The quantum of cosmos past, present, future of quantum cosmos, the theory of everything, what is missing in it. So it's all quantum, or, is it really? So welcome, Chris. Thanks so much for joining us today.
Well, thanks for having me.
So to start with, the three guys that won the Nobel Prize for Physics in 2022, Elaine, Anton, and John, sounds like a song, who basically worked with entangled photons. But here's where my head hurts. They also proved that the universe doesn't really exist, at least locally. And when I think locally, I think of like a zip code. So give me the thumbnail sketch about what and also last week at, where was it? Brookhaven, they kind of actually did it with little tiny things, but they did it. So give us a thumbnail sketch of that.
So they're experimental physicists. They performed these experiments as cited in the Nobel Prize press release called Bell experiments. And so these are about looking at correlations between, as you said earlier, photons in this case, that have been separated many, many kilometers. So we can do these experiments across islands in the Atlantic Ocean now. And it's delicate experiments that look at the correlations of quantum objects like photons. And some of these experiments involve atoms as well. Now, I don't think that anyone would be so presumptuous to state themselves that their little experiments proved that reality doesn't exist. These are sort of the things that get stuck on by science journalists and commentators afterward. Yeah, they didn't prove that reality doesn't exist. The thing, yeah. So I mean, that's the thumbnail sketch of it, right? Quantum physics is an enormously complicated subject, right? A rich history, over 100 years old. But I think, it's in some sense up until now culminated in being able to control it to the point of using individual quantum systems like photons and atoms for new technology. And that's essentially why they won the Nobel Prize, because their research led to what was cited in the Nobel Prize press release was quantum information theory.
Well, it's interesting because for the book that we're talking about, you kind of brought it to a level where, the lay person, if you will, understands it, but more erudite, not erudite, but a little more into it than, say, Neil deGrasse Tyson or something like that. But on the other extreme is, your book, Quantum Entanglement for kids, babies, because you like to do those balls, and you have a ball and ball, and then they're both red or they're both spinning the opposite way because of conservation of momentum, angular. And then you separate them, and you're telling the baby that no matter how far you separate them, one spins one way, one spins the other way, one decides, hey, I'm not going to be this color, the other one's the other color. So, and that's what I was kind of alluding to in the introduction. They may not understand it, but it kind of gives them this vague, nebulous idea. And I think that's what you're looking for, right? Because sometimes you get criticized, this is way too tough for them. They don't understand the words. But
sure, yeah.
And you said in your talk at your old university, that's not that important, really, right?
Yeah, I mean, at the end of the day, the important thing is that you're reading to your child. It doesn't really matter at that age what you're reading. Do you need to instill this routine or this idea in them that reading is important, right? The sooner you read, the sooner you get to go off on your own and be an independent thinker. So I think that's the most important thing. But reading, you could read about what sound a cow makes, or you can read about the basis of our understanding of the world. So I prefer the latter over the former.
Well, the thing about when I said what the media says, oh, they proved the universe doesn't exist. But then I always ask any quantum physicist, and I ask other guys who have attempted to formulate an explanation where the seat of human consciousness lies, which goes to very small to very big thing. And I always ask them, and they get pissed off about it, is what if it's a solipsistic universe, which kind of, it's irrefutable, but in which case one of us is here and the other one is just not there, but a simulation of something. But they always say, no, you're there and that's your books. But then they go, well, it could be a virtual background. It's not, but it could be. So how do you argue against, if you can, or do you just miss it out of hand and think I'm being silly, against the solipsistic universe? It always bothers me.
As you said, there's no way that you can disprove it. I mean, all I know is my own experience, and everything else is filtered through that experience. But my point of view is that if this is a simulation, or if it's just me, my brain sitting out in empty space, just imagining everything around me, I wouldn't behave any differently, because in that simulation, there is another person, and that person is going to react to the things that I do according to the rules of the simulation, right? So it doesn't matter if those are real rules, this is a real world, and those are real physical laws, or if this is a simulated world and those are simulated laws. I should act differently in either case. So it really, in some sense, it's not worth worrying about and thinking about, because you wouldn't really act any differently, right?
No.
In the real world or in the simulated world, you can take actions, and those actions have consequences.
Yeah, it's like your moral compass wouldn't change because, yeah.
Yeah, I mean, it's not going to work in a simulation or in the real world in a court to say, well, that wasn't a real person that I killed, right? In the simulated world, they're still going to say, well, sorry, in this simulation, you still go to jail.
What about the like corollary of it, like Einstein's famous, spooky action at a distance, sorry, or to say that if we don't look at the moon, it doesn't exist. It's not there without the observation, going back to what you talk about, Schrodinger's cat. Again, these are all kind of cliches now. But I remember when I was a kid, I had this dream that when I went to sleep, my parents took the universe apart because it wasn't necessary because I was sleeping, you know? And
Right.
that kind of made sense to me. It would have been a lot of work, but still they could have done it. So I guess now everyone's saying, Einstein's proven right so many times, but in this case, he's proven wrong, which kind of bothers me because I always like to think that, when he says the cosmological constant was his, biggest error or whatever, but explain why he was wrong if you think indeed that he was wrong.
Yeah, I mean, Einstein was wrong about a lot of things, probably. I mean, he, he said a lot of things that he didn't put to print, right? So what's in every one of his papers is correct because he used logic and reason. So he set out some assumptions and then deduce things from those assumptions, right? That's how logic works. When we say Einstein was wrong, we often go back to like his personal writings and like personal conversations between people. And, I don't think it's fair to say like, oh, well, he was wrong about this or that. And that's somehow important because, that imagine after you die, if someone goes back and looks at your text messages and starts saying, well, he was wrong about this and he was wrong about that, right? So that when we say Einstein was wrong about quantum physics, it was sort of his personal motivation seemed to be to find a different theory that underpinned quantum physics. So quantum physics is what's known as an operational theory. It tells you like the recipes for what you should do in a lab to observe certain things, lights going on, detectors clicking, that sort of thing. It doesn't say anything about reality. It just says, if you do this, press these buttons, turn these knobs, and go and wait, then at the other end of the lab, you'll see these lights go on, right? And it's very good at that and remarkably accurate at predicting what will happen. But there's nothing in quantum physics that says, oh, this is what was really going on when you did that. Einstein wanted a particular kind of theory that told him what was going on. And Bell's theorem, that's what the Nobel Prize was awarded for, says that you can't have that. Now, Einstein never wrote a paper about that had to be the case. So in his scientific writing, he was never proven wrong. He was only his personal desire for what a theory should look like for quantum physics just is not possible. So that's sort of the sense in which we can say he was wrong.
That makes me feel better. Well, see, the questions I'm asking you now are questions prefatory to trying to sell your book. Another one that always bothers me is the anthropic principle. And, you can do all these examples, like if there was a little bit more oxygen, everything would catch on fire. If there was a little less, we couldn't breathe. But the one that always gets me is the fact that basically ice floats, stuff when it gets hard drops. But if ice dropped, then we wouldn't be here because all the fishes would be dead. They wouldn't have been able to swim or be around in the wintertime. So how do you feel about either the strong or the weak anthropic principle in your studies?
It doesn't really come up in my technical work. Personally, I think it's pretty good. You imagine that it's about expectations, personal expectations, right? So if I look out in the world, what do I expect to see, right? I expect to see things that are good at replicating themselves, right? Because the things that can't replicate themselves would have existed briefly and then died, right? So I think there's sort of the anthropic principle at work, right? It's about what do you expect to see in the world, and you expect to see well this, right? Like the stuff that's around us, the stuff that was able to exist and remain in that state for a long period of time. I mean, it could have been lots of other ways, but if it's not solid, if it doesn't maintain its state and replicate the information before it decays, then I probably wouldn't have seen it.
Well, if going back to Einstein, he says, if you don't look at the moon, if a tree falls in the forest and you're not observing it, it doesn't make a sound. So you do that kind of on a very large scale. But when you talk about observation on a smaller scale, it actually holds true that it's whether it's the double slit experiment or something like that. When you're looking at something, you see it. Or, I mean, I don't call a friend for a long time. I have no idea whether he's alive or dead because I haven't interacted or observed him existing. I mean, my friend Joe Clark, who I've known for 50 years, he doesn't respond to my texts anymore. So I don't know if he's dead or alive. But
I hope he's alive.
yeah, he's a great guy. but
Get out there, Joe.
Maybe he'll listen to this. But it actually does happen because, not being able, when the wave function collapses, when you're not able to tell whether an electron's moving this way or where it is, you can pick and choose. So does your observation actually collapse the wave function? And then doesn't that actually have to do with you? I mean, doesn't it have to do with you rather than the existence or not, the location or not, the acceleration or not of a specific particle?
Yeah, absolutely. I mean, quantum physics is a rule book. So you open the textbook and it gives you like a guide, a Boy Scout's guide to the universe, right? Doesn't tell you what is really going on, the motivations of the things in the forest that might harm you. It tells you just what, the tools you have and what to do with them to get along the best that we know. The moon isn't there when nobody looks, because the concept of the moon is vague and ill-defined, right? So I mean, every time I look at the moon, it's probably subtly different in some way or another. And so I mean, the moon, right, contains a lot of context that we don't think about. So you're in the northern hemisphere and you see a man in the moon, right? They don't see that in the southern hemisphere. It's upside down. So I'm in Australia. When I look at the moon, the first thing I notice is, for me, coming from Canada, is the moon is upside down. There's no man in the moon for me, right? So the concept of the moon is different for me than it is for you. And I think that's the real challenge when we talk about quantum physics, is that the proper language to discuss quantum physics cannot be translated into English or any other language. So we have to make do with analogies. And as you know, analogies eventually break down. And it's at these points where they break down where the confusion sets in, and we think it's somehow mysterious or confusing, and it's going to teach us some deep thing about the world. But that's not the case, right? It's just the fact that we don't speak the language of quantum physics.
Well, it's like, and you talked about this and when you went back to your school, the older view that we grew up with, and I learned obviously, is that, atoms are a solar system and these guys are spinning around them. Who did that? I forgot. You told me, but
Or
yeah. So then now that's, as you say, it's just all fuzzy, and the solar system idea is not a good metaphor, just like the quarks, up, down, strange, that has nothing to do with anything. And then you think back to Feynman and his, talking about the bird and that his dad taught him, And, the idea that the name of anything has nothing to do with what it is. And so you call it the moon, but that doesn't have anything to do about what it is. And these are questions, I had these same conversations in my dorm room at 3 a.m. in an altered state of consciousness in the 60s and 70s. And I never really got any answers. And I'm not putting the burden on you to give me answers. They're just things that you ponder. And going back to selling the book. And
I think you should ponder them, right? And ultimately, I think that's, if you want to say what should I do with my life, or what does this all mean, then I think that's it. That's pretty much it. Just ponder, think about things. There's no answers. There's no simple answers to any of these questions.
And that's part of the idea that I have. Well, first of all, I wake up every morning going, what is this? Where am I? Which is pretty bad for a 70-year-old. But it's like, the thing about what I said at the outset about difficulty in understanding something that you're inside of. It's like you have a broken screwdriver and you try to fix it with the screwdriver that's broken. It's kind of meta, but so how do you get around that? That it's like the set of all sets. You're inside this thing, and yet you devoted your life in good part to understanding it. Do you ever come up against this wall of the fact that you're inside it? You'll never be able to see it. It's like you'll never be able to see if there is a multiverse or a froth. Does that frustrate you?
No, I don't think so. Yeah, like I said, it's like the scout that goes into the forest. I don't think they really worry too much about, I can't zoom out and fly above this forest, and the task I was set out to get my latest badge would be so much easier if I could just fly over this thing and just only see the canopy. Because if you really thought about it, well, that would be kind of boring, right?
Yeah.
But when you're down in it, you don't see it. You don't see the whole forest, right? So I think you can't have these things simultaneously. But I'd rather be down here than up there.
Yeah, it's like going through a really complicated maze, a labyrinthine maze. If you had a drone that had a camera, you'd be able to get out of it in 2 minutes. Otherwise, it's going to take you days. I don't know which way I come down on that. But back to the book, and I tend to wander around and talk too much. But so back to the book, why did you phrase each part by using quantum as the first word, when most of us think of quantum as, like I said at the outset, a tiny, tiny little thing? Yet you're kind of like using quantum, even though you're describing the largest thing that we can imagine and beyond. How did you approach it that way? You and your co-author, how did you approach it that way? Well,
maybe we could have started with this, or the whole motivation of the book. It's a bit personal. It's probably not admirable. I look out and I see science communication and these science communicators, and they have various disciplines, especially in physics, astrophysicists, high energy physicists, string theorists. But when they stand in front of an audience, they just put up pictures of galaxies. And so they're always talking about cosmology, even if they're not a cosmologist. So I felt like there's a deep misunderstanding about what we understand in terms of physics and cosmology and astrophysics. Because at the end of the day, almost everything we know has its roots in quantum physics. So everything we can say about cosmology has its roots in quantum physics. If we didn't have quantum physics, we'd still just be looking at points of light in the sky and making up fake stories about what they might be, right? So even the fact that every one of those points of light is a star made of mostly the same stuff comes from an understanding of quantum physics. So my motivation for the book was to really point that out and emphasize that and bring quantum physics up to the popularity level of cosmology, right? That it's quantum physics that tells us and underpins everything we know about the universe, not to mention all of our modern technology. It's the most important scientific theory ever.
If you go back to the beginning of your book and the universe, and you are actually dealing with something, a point, a singularity, the very beginning of whatever, and we can't go beyond that either. But if you're talking about the very, very beginning of it, what about someone saying, or you saying, that there was a quantum fluctuation from which this computer and you and everything around me, and again, Feynman talks about that, here you are, as he says, with these little appendages here. And how did we get to that point? And you talk about that, and just like the idea of when the universe stopped being opaque and became transparent. So if you had to explain again to a baby, maybe you've written a book about this, how it all began, how would you be able to begin to explain it, either with your ball or something tiny?
Yeah, that's often glossed over, for sure, that we hear about this all the time. I mean, there's a popular TV show called The Big Bang, and the theme song kind of attempts to explain it. It's our best theory at the moment, but it has its flaws and almost surely wrong in some way or another. But I mean, it's I guess the mystery that's often glossed over, as you say, is it seems strange to go from something like tiny and simple to all of this complexity that's around us. But a simple analogy is, imagine you drop a milk in a coffee cup. So you got the white, bright spot of milk and then black coffee, and you just let it sit, and you see eventually you get all of these really intricate patterns, and you can zoom in, and it doesn't matter how far you zoom in, you see these more and more intricacies in these patterns. And you might ask yourself, well, how could that have come about? I just put a tiny little drop of milk in the coffee, yet now I see all of this complexity and all of this things that I might say is meaningful or in that milk and coffee mixture. So I think that's a good analogy to realize that complexity can arise from simplicity. So for a physicist, it's not that surprising. We often don't have this cognitive dissonance between, the universe started in a very simple state, and now it's a very complex state, because that's almost a natural sort of thing that happens in the world.
I can understand that, but what I don't understand then is how, maybe there wasn't, how this enormous, beyond any comprehension amount of energy was released at the very outset. Because it seems like, equating it to mass, that there had to be something incredibly massive, and maybe, white holes and black holes, but there would have to be something. How could there have been such an enormous amount of energy at the beginning that would give rise to this inflationary period and this massive expansion?
Well, I mean, I guess you could appeal to the anthropic principle again, right? So you imagine that fluctuations can be small or they can be very large. There's no upper limit on how big they can be, but small ones are more numerous than large ones. But if there's a universe, or say multiverse, that is infinite in extent in space and time, or any other dimension or concept you might think about, then eventually large fluctuations will happen, right? This is the fluctuation that created ours. Probably not the biggest, right? There could be bigger ones. And if you wait long enough, then you'll see one. And you ask, well, in those fluctuations, eventually complexity will arise, and maybe it'll be complex enough that the stuff in the universe gets together and starts asking questions about itself in the universe. Then Well, it's going to be those large fluctuations that contain those things, right? The small fluctuations won't have people in them,
I
and the
guess
very large ones might have people in them, and they'll ask the same questions, right?
and
So it's,
there's a
again, it's about expectations, I think.
Yeah, and I understand in an infinite space and time, there's another Zoom interview going on in which your glasses aren't on, a tiny, tiny bit of your glasses aren't on, or I have more hair than I have. So I guess the definition of, I mean, it seems if there is a fluctuation, it sounds like there's a fluctuation in something, in a field, but there couldn't be a field because there wasn't even space time. And once you get to the Planck length, there, all the laws of physics break down. And you talk about that. So there really weren't any laws of physics at the beginning. And these are unanswerable questions. I realize that, but there's still questions that I ponder. So, and you're right, I should ponder them, but I can still ask you because you're the best person to ask. So, and I know it might be tedious for you, but so yeah, at the very beginning, we still use a word, fluctuation, which implies to me change, movement. It's something different than what was there before. What is a fluctuation?
Well, I mean, the word fluctuation usually involves the concept of randomness, but then again, you get, as soon as you talk about it in those terms, you get back to the point that you made earlier, that these are personal stories that we talk about when we talk about physics. And random just means I don't have the information I need to make it not random, right? So random is a concept that refers to my own ignorance about what could have been. So when I say the roll of a die is random, it just means that I don't have the information necessary to predict exactly what will happen. So it's a personal sort of thing. Right? And then you could say, well, you know, the outcome of the die fluctuates. Right? If I come up with some theory, statistics, right? That's the sense in which we're using the word fluctuation. It's about me and my stories that work well in describing the universe and the properties of those stories. So I think a lot of times you will, you know, you'll worry and you'll think about these questions, and definitely you should, but I think you can kind of take a different point of view and remember that what we know, or what we think we know, are stories made by humans for humans, usually for ourselves, about our expectations of what we're going to see when we take actions in the world.
Yeah, but that's no real different than Greek deities, because those were just stories too. I mean, if you talk about Zeus or his father, they're trying to get to a beginning. And you talk about turtles all the way down too in your talk, which, you know, okay, maybe there are turtles all the way down. I don't know. And then you take the James Webb telescope. It's got, you know, we've already seen back to like 500 million years before, after it started, and James Webb will take us closer, farther back. But what's the point? You're going farther and farther back. You're never going to reach the beginning. But so what can you not only experimentally validate, but infer, intuit as it goes further back? Because you're going to get closer and closer to something. It's observation.
I think most scientists do things primarily because they can. You know, they're doing the same thing as all of us. For experimental physicists, they build things and attempt to make more and more extreme observations, or observe things outside of what we can see just standing here with our own eyes. Others take that method, but apply it to our imagination, I think we're all doing the same thing. And we do it because we want to, because we can.
Well, it goes back to what you were saying about your initial dream of this book. Your part of what it was the way it was being approached wasn't necessarily the right way to approach it. But the other part of the dream is, like, when did you first realize, maybe when you were a baby, when did you first realize, one, this was like, what the hell is this? Or how can I figure out more about it? And why did you make it the passion, your passion? What was it that keeps, you're talking about stories. You have a story.
Yeah, I mean, my life has a story. The entire details of it are probably not interesting. Even the one I tell myself is simplified. Certainly, I make myself out to be the hero of my own story, as all people should. Otherwise, you can get quite depressed about things. But if I look back, actually, it was probably not the best motivation. I didn't necessarily think that I would end up here. It was the opposite. The problem, I think, and maybe it's not a problem, I haven't thought about it too much, is that we often give this perception as scientists, popularizers of science communicators, that there are simple answers, right? There's simple answers. They're in books, and if you read the books, you'll have the answers. So that when I was young, I was incredibly naive. I thought, the policeman knew everything about the law, and that was sacrosanct, and the doctor knew everything about health, and the lawyer, knew everything about court proceedings. There was just, a finite set of facts in the world, and there were specialists who knew about these facts. And that means the science teacher knew everything there was to know about science, and the physicist knew everything there was to know about physics. And I thought to myself, in high school, well, that's pretty cool. Where do I go to find out about all the facts? And I was told to go to university, and at the university you have a new series of textbooks, but that was it. You go to university, you read all the textbooks, and then you'll know everything. And it was probably grad school where I realized that it's the opposite. We know nothing, right? We essentially know nothing. And then I spent the next 15 years of my life, grappling with that fact, to the point where I'm now comfortable with it.
In the very beginning, did you believe in God?
No, I mean, God is something that you believe in because your parents told you about it, and my parents weren't religious, so it was something that never came up.
Would you say it's a passion?
What I do?
Yeah.
Yeah, absolutely. I mean, what I do is I think about stuff, and I write down what I think about, mostly for myself, because I think about so much stuff that I can't keep it all in my head. So I use, a computer or paper to extend my own understanding. Hard drives and sheets of paper contain my previous thoughts that I can go back to, and I can't not do it. That's in my nature. I just need to think about stuff and write it down.
That was a good explanation. You got too much stuff in your head to keep it there, so you write it down. Never thought about it that way.
Well, it's actually, if you worry about things like, what is the point of all this? What is the meaning? And you think about it from a scientific perspective, our best model of the universe is like the coffee cup. We're sitting now at a place where the complexity is thriving. But as you know, no matter how many times you put a drop of milk in coffee, you always end up with this kind of brown latte colored soup, of nothing. Nothing interesting in a latte. Plus, you should just have black coffee because it's better. And so that's what's going to happen with our universe, right? Complexity is fleeting and will eventually decay into essentially nothing. So what should you do about it? What should you do about that? You know, if you want to be the hero of your own story, then this decay, this inevitability of the end state of the universe being just the latte universe of nothing, what you should do is write things down. Take the thoughts in your head and crystallize them in physical objects like paper or hard drives. And this is the only antidote to decay. You encode it in a way that it will last as long as it possibly can. And the best way we know how to do that at the moment is to encode it in physical objects like hard drives. And put it on the internet, and the stuff, so far as we can tell, the stuff that's on the internet will if we shoot it off into space, it will outlast the our sun, which will die in 4 billion years, and it will outlast our galaxy. It could be the last thing in the universe might be something that you wrote down. So that's sort of my best attempt at deriving a meaning to life.
It's funny because, that made me think of something you talk about in the book, which is entropy and tending towards disorder, which then reminded me of your one YouTube video where it was a really cool one where you had the red and it's always John and Mary. Is it always John and Mary?
Oh, the characters, Alice and Bob. Yeah.
Alice and Bob, they're everywhere. Alice and Bob are everywhere.
Yeah.
But I guess that's like something you guys do. But the one you did was the cardboard box with the hole in the middle, and there's 2 different color balls, and then you shake it up. They're in total order. And then you explain entropy to babies by shaking it up and showing when you shake it up, it's always going to get all jumbled, and which is entropy. And which leads me to, okay, that's one passion we talked about, but apparently, certainly seems like the other passion you have, especially when you sit at the table with your kids, is this idea of inculcating. You can talk about 1 to 3-year-olds. When did that start? And why is that so important in your life? And why do you keep writing so many books?
Well, the reason I write books for kids is because I have kids of my own. I mean, if you talk to someone my age without kids, they're just not even aware of this sort of other world of children's books and what's in those books and what is missing in that literature and what the opportunities are. So it was, because I had children that I started writing children's books. And, I write about science because that's my area of expertise. And, it just so happened that was a niche that wasn't filled. That's sort of the easy answer for why I did it. But again, I think it's important that parents show their children that science is an important thing, and reading about science is probably the best way to do it. Show them that you are excited about this topic, that you're going to learn something new, and it's going to lead to questions and fun things to ponder. One of the things I realized kind of after writing the books is that parents, especially in Western cultures, have this this fear, this anxiety for things like science and mathematics. And oftentimes it comes from their education. So they'll say things like, "I hated math in school." It's a very, very common phrase. It's a very strange thing, actually, to tell someone when you meet them and you ask them what you do, and they say, I'm a mathematician, and then your response to them is, I hate that. But apparently that's encouraged in Western cultures, to not be good, let's say, at math or science. And then what I find is that when these parents, they read these books and they say, oh, actually it's not as complicated as I thought it was. And that in and of itself is a win, because the opposite is very dangerous. So if a parent says, I hated math in school, and then a child performs poorly just on one question or one test, then that they just default to the position that their parents were in, right? That, well, mom and dad didn't like math in school, said they're not math people, but look at them, they're successful, so apparently you don't need this, right? But we navigate the world using science and math, even if we don't think that we do. And the more you understand about the tools that you have, the better off you'll be.
I agree with that. It's like when you're talking about STEM, and then you kind of say it's politically correct now to turn it into STEAM or stream, just to make sure, okay, we got everything here. We don't want to just say it's science, technology, engineering, and math. But that leads me to the question, okay, so quantum physics for babies, rocket science for babies, yes. But when you get to Bayesian probability or blockchain for babies, as some of your critics might say, okay, this is too much. Which goes to my idea, it's just reading and it's just words. But since they don't know what Bayesian is, and you don't find the term in the book, it's back to the balls, which the balls are really good. It's a really good analogy because kids like balls.
Yeah.
But yeah, so you get to Bayesian or blockchain, that's really tough. I mean, because at the end you go, now you understand. But
yeah, I mean, there's a bit of tongue-in-cheek humor there, right? Yeah, I mean, some of these are fairly abstract ideas. I mean, abstract concepts aren't something that naturally going to be absorbed by children, but the beauty of children's books is you have to read them every single night. So
right.
My favorite quote from one of the most brilliant people that ever lived, certainly the most famous mathematician of the 21st century, John von Neumann, who is responsible for many things, including the computers that we are using to communicate right now, said, you don't understand mathematics, you just get used to it.
Yeah.
So it's this practice, this repetition, that gives the illusion of understanding, but at the same time, it is understanding according to our best conception of the term. So the sooner you start, the better off you'll be in the long run.
Yeah, board books, that's what I sell. I mean, one of the many
Excellent.
things. And the other thing that I really like, and I think is the best way to, your idea of life is to gain as much information about the universe as you can, which I think is a noble goal. But the other goal, and why I have a bookstore, first of all, you want to make people happy when they come in. Second, you want them to have fun, and then games, and then play. I think those are like, games and play are a wonderful way. Or if you have humor in your book, it leads the reader along, It's like, don't just give them dry information, which you kind of talk about with other scientists and popular science writers. But the idea of having humor and creating a game, don't you think it really fosters that spark that you're talking about in the end of each book?
Yeah, people respond to many different things. I mean, I guess a common thread is stories, right? And stories can be humorous and stories can be playful. Games are acting out a story, right? When you play Monopoly, you're in the world, you're the capitalist, and you play out the story. At the end of the day, I think is the thread that connects all of these things. And some people respond to less interpretable stories. So science is often of that flavor. It's still a story, but the idea is that you leave very little room for interpretation because you're trying to avoid confusion and argumentation. Whereas poetry is the opposite, right? The point is to take something simple and make it as complicated and interpretable as possible. So some of the books in the For Babies series are quite abstract and very sort of factual, very, very dry, I would say. But that's what some people like, and that's what some people want. But it's still a story, right? Every book starts with "This is a ball," and at the end it says, "Now you know whatever it is, Bayesian probability." And the point is for it to flow like a story. But in these cases, it's not, except for the one you mentioned with Alice and Bob, often don't have anthropomorphized objects as main characters of the story, which as humans we often find it easy to respond to when we can relate to the characters in the story, but not everyone's like that. So I don't think there's one right way to do it, and that's why I have a variety of options and methods to convey the ideas that I have.
One of the best stories you do is the rocket ships, because you take the ball and then you describe lift, and then you change the shape of the ball, and then you turn it sideways. If I was a kid, I could kind of get that. That's a good one to get, I think. And it's also a real thing. But the thing about it is that you've used the term story so many times in our talk now. But other people are going to think a story is not real. It's just something about something. And so it seems, you've actually kind of said it, that everything in our life is just a story.
Yeah, absolutely. Even me, I'm a story.
Right.
I'm a story that I tell myself. And science, you should think of not as a collection of facts about some objective reality out there, but it's a collection of stories. We call them models or theories. They're written in complicated languages or mathematics, but at the end of the day, they're just stories about what we as humans find important about the observations that we make, and we do that because we want to communicate them with other people, and that's what humans do. They tell each other stories.
Well, a good way to conclude this talk is like the very end of the book. You talk about, well, I'm paraphrasing, I guess. You talk about the theory of everything, and then you talk about, what's missing here, or what's absent, or something like that. So there is this standard model, there is this theory of everything, but it's not at all. So there's a story. That's really a story. The theory of everything. It even sounds like a title of a novel. So you got this theory of everything. So obviously there's something lacking. Articulate for the reader, for the people I hope buy the book, the ending is that, what's wrong with the theory? What do we,
Yeah, I think that last chapter really emphasizes this point that all the things that we talk about are stories. It's not reality. A story isn't it's not the same thing as reality. So when we say the word photon, it's not the real thing, the real phenomenon in the world, right? It's part of a story. And if now you try to extrapolate this very sort of meta concept to its natural conclusion, well, can't I just have a story of everything, right? And so that's kind of what a theory of everything would be. We don't have a theory of everything, and some people don't think we could or ever will. I think what we will have is more refined stories we have these paradigm shifts in science, and in the book we talk about what scientists imagine that might look like, what would be the consequences if it looked a certain way versus another way. But we don't want to give the idea that there is a story that humans can have that encompasses everything, right? If a story replicated reality, it would be useless. It would just be a mere duplication of the complexity that we're trying to simplify and communicate with each other. So necessarily, these stories can't represent reality.
Yeah, otherwise it would be a Turing machine, which would be the whole thing. But now, if I was okay, I always think I'm asking the last question, but then if it's a good book, there's always another question. But
Yeah, great.
Okay. So you said again, we're talking about stories, but then now I'm really trying to paint you into a corner. Then you said it's not reality, and that's, you can't get outside. So, okay, stories aren't reality. So then what is reality? It's not a story.
No.
What is it?
I mean, the word reality, I think it is contained in stories, but words are always overloaded with definitions. So there's my point of view is there's something out there, right? That's the usual sense in which when we think about it carefully, when we talk about reality, that's there's something out there outside of me, right? I have my experiences, and my experiences are filtering something out there, and that thing, whatever it may be, is reality. So my stories are about that thing, but I'll never be able to know, in sense of the word know, what that is.
That's a good ending. That's a really good ending, because I don't necessarily, from your book, I don't necessarily know the ending, and I don't know what's out there. And that's not the point of your book. The point of your book is to, in my opinion, is to tell the stories and to have the stories help you. Okay. Last question. So you wrote it, you write the baby stories. So you wrote this book for me, for the adult story. And so the reason I like certain books, and I think they're good, is because when you close the cover, you're not done yet, and I'm not done with the book. I read it, but I'm not done with it because there's all kinds of other stuff. Would that be a part of the reason? Would you articulate that would be the reason you wrote it?
Yeah, I think we were at a state in science communication where we seem to think it's okay to stand up in front of audiences and write books where we authoritatively state that these are the facts, and this is what we understand about the world, reality. And people walk away feeling very confident that they have a simple answer to how everything is. Whereas Geraint and I, and myself in my other books, don't shy away from the fact that that's not it. There is no simple answer. We don't have a simple answer to all of these questions. We have simple stories, and they're simple for a reason, so that we can communicate them about what we see and observe and in the world with each other. But what's out there is far more complex than what our stories show, right?
Okay.
And that I think that gives the reader, you and others, a jumping off point to think more about this.
Yeah, and it certainly has. And I think the people who come in find this book, where it's been, in science and on the front table sometimes. That's what I think is, and that's how, and also, and we have a nonfiction book club, and it's one of the books that's coming up. And those questions, that what you're saying, sometimes some scientists are going to tell you this is the way it is, and this is the model that works. And you're saying, no, it's not. This is something. And that the best in this interview, for me, the best thing is the idea that you're talking about stories, and then reality, and the way you explained it is that there's something out there. And maybe you even think that the universe is tending towards something. But yeah. So in any event, thank you so much. Sorry for me going on and on, but there are questions I have always had, and you were a really good person to ask those questions too.
Well, keep asking questions.
All right, I will. Thanks so much.